So I'm going to start with a very basic model, and some of this might be really easy, but then once we get in past the easy part, we're going to go into the advanced processes, which will be in the future video. But go ahead and check this out. Just make sure that you follow along so you can see some of the concepts such as, inside bend radius and K-factor, and making sure that you're modeling your stuff correctly, regardless if you know how to do it in SolidWorks or not. So just going to start with a really basic process. So I'm actually going to just draw a part that is, let's say, like this. Okay, going to give it an angle here. So really simple part. And actually, from this point, now we can go directly to the sheet metal tab. If your sheet metal tab is not live, you can right click. And inside of there, you'll be able to find, the sheet metal tab, so it populates up here. So I'm going to do base flange tab, and that's going to let me extrude the sheet metal component. I could put this on either side, right? And then I'm going to use a 0.0775 inch inside radius because I know I'm bending 1/8 inch, and I'm referencing to a chart that I'm going to show you in a future video. I'm going to extrude this out 4 inches, and bam, that's our most simple part we could possibly get when it comes to doing sheet metal, right? And then we can normal cut into it and do all sorts of stuff like, for example, we can cut a hole right here. And when we extrude cut through that hole, it normalized cut it, and that's because it had checked this normal cut. If we uncheck it, which is what it would do by standard, is it would cut it as if a drill bit went through it. But that's not how a laser is going to cut it. We're going to cut it, perpendicular to the surface. So what this normalizing does is it makes sure that we're cutting perpendicular to the surface, so clearance is what it needs in order to make that happen, which is pretty cool. Another method that we can do here is, for example, just draw on a plane. I can draw, a square, and I can extrude it out, 4 inches. And then I can do something called convert to sheet metal, which is really helpful. So sometimes when you have some pretty complex geometry, you can draw it as like a solid block, and then you can convert it in. And there is some limitations to this, but it is just only for like some simple parts, easy to do, maybe if you're doing some like tabs or whatnot. So we're going to make sure we're going to convert it. You can see it's doing some end relief here. You got to sometimes play with that, and we're going to change that to a tear. So right there, and then right here's the gap, so you can see it's got a gap right there. I'm going to change that to like 5 thou, and then I'm going to make sure my radius is 0.0775, and you'll see that on the chart later, and then convert it. And there we go, now we have a sheet metal part that unfolds. And one of the key things that we make sure is that when we unfold our parts, that they're not overlapping edge to edge. So that's a pretty important key factor in this. So two concepts here. One, just extruding from a line a sheet metal part or a base flange tab. And then the second is just taking a solid object that could be all sorts of different shapes and converting it. So like where this would be helpful is let's kind of back it up a little bit. And let's make this a little bit more complex. Let's just cut it. It's not even that much complex, but just showing you what you can do with this. So we'll cut all the way through the block, and now we can use our convert the sheet metal, and we can click the face, the edge, and the edge. So now we just like added this return in there, which is pretty cool, just by doing it off of the model. And then I could have even had the sides bend down if I wanted to, and go back to bend edges and fold it down. So now you can kind of see what's going on there, and you can see that's the edge gap. That's still it looks like it defaulted back. Yep, sure did. And then we'll change it to 5 thou. So there we go. Now we have a part that's driven off of a solid body. So this is the absolute basics to sheet metal, and the next one we're going to go into is checking out the actual chart on what you need to look for when you're designing this stuff.